Hey guys, welcome back. Today's video, we're talking about transformations of polynomial functions. And specifically, how do h and k transform a function? So h and k are these variables that transform a function, and I'll show you what it looks like in just a second. Just as a quick review though, you've already done transformations before. Back in geometry, you used to transform polygons, lines, triangles, rectangles, all that kind of stuff. And they were called rigid transformations. So if you remember how to do rigid transformations from your geometry class, probably going to do okay in this section. Now, rigid transformations, there's a bunch of different types. And what we're going to focus on today are just one of these types of rigid transformations. The one we're going to focus on is translations. Translations is what we're going to try to do. We're going to try to translate functions instead of just shapes. So if you remember from geometry again, translations are slides. It's like one way to remember what a translation is. You take something and you slide it around, kind of like on a Ouija board or whatever, right? Now, for polynomial functions, if I have one that's called like f of x equals, and we'll just go with something really basic for now, f of x equals x cubed. Transformation form is taking this function and moving it around. We're going to transform f of x. So here is what transformation form looks like. You're going to want to know this. It's very important. So when I take a function and transform it and create a new function, here's what transformation form looks like. Transformation form. I'm going to transform f of x using this new function. So I'm going to identify this function as g of x equals a times f of cx minus h plus k. This should look a little bit familiar. We kind of did this with quadratics, especially with a, h, and k, whenever we were working with vertex form. So this might look extremely confusing at the moment, but once I kind of walk you through this process, I think it's not going to be so bad. And the two variables that we're focusing on today are the h and the k. In another video, we'll talk about what a and c do. So with all that said, let's try to come up with definitions or at least descriptions of what h and k do to a function. So again, we're going to try to come up with definitions for both h and k. Later on, we'll come up with definitions or at least descriptions of what a and c do to a function. All right, so let me go to a new screen and make some functions. So go to Desmos to make this stuff clear. So I've already defined a function. I wrote it down there as f of x equals x cubed. This is a polynomial function, right? Where the exponent is larger than, or well, where the exponent is a whole number, essentially. Okay, now what I'm going to do is transform this function. I'm going to move it around. So g of x, here's transformation form, a f of cx minus h plus k. Got sliders. All right, so let's make the h value 0 and the k value 0. All right, so at the moment, no transformations have been applied. You see how the red function f of x and my transformed function g of x, the blue function, they are directly on top of each other. So all I want you to do is just pay attention. I'm going to start changing the values of h and of k, and you can see what happens to my transformation. So if I make, actually just, I don't know, watch. If I increase the value of h, I see what's happening to my function. If I go this way, if I make h a negative number, going in this direction, So changing the h value, what's happening to my original function? Hopefully you're able to see that very clearly. Now, let's play around with the k value. If I start changing the value of k, when I increase the value of k, you can see where I'm going with my function, right? If I decrease the value of k, you should also be able to see pretty clearly what's happening to my function. You can also just hit like the play button. What's happening to this function as it increases and decreases? What's happening when I change this k value way off to the end? So I hope that gave you a decent visualization of what happens, at least what h and k do to a function. So let's write about it in our notes here. Let me go back to that notebook thing. So h, I said this for a reason, translations, right? So h and k, what do h and k do to the function? H represents a horizontal. H represents a horizontal, or another way of putting that would be it moves the function left or right. Every single point on that function, it moves left or right. So H is called a horizontal shift. It shifts everything in the function to the left or to the right, depending on its value. Now, K represents a vertical shift. By vertical, I mean it is shifting the function up or down. Okay, so let's go back to that graph one more time. I'm going to make a little bit more of an advanced function. So let's change this back to 0. All right, so f of x. I'm going to change f of x to a little bit more of an advanced function, right? So let's make this like x to the power of 5 minus x to the power of 4 plus 6x. Actually, 6x cubed minus 4x squared. All right, so this one, got a little bit more going on there. I guess not entirely too much, but you still see that my red and blue functions are on top of each other. So hey, that's the benefit of having this transformation form in terms of f of x, g of x, this transformation. I'm transforming whatever this function is. Doesn't matter what kind of polynomial function is typed in here. This will transform it, this form. And h and k, they never change. They're going to be doing the same things every single time. Like if I make the h value of my transformation 5, it just shifts the function 5 units to the right. Maybe I'll go 3 so that way we can actually see it. H value is 3. I move my function 3 units to the right. So instead of having a point at 0, 3, I'm going to have a point at 3, 0. All right, pretty clear. So then the k value, remember that moves the function or shifts it, translates it up or down. So if I make the k value like -2, it's going to take this function and drop it down 2 units. OCD there, we've got to make it -2. All right, so now this point of 0, 0, I shifted it 3 units to the right, and then I shifted it down 2 units. Every single point follows that same exact sequence. It's going to go 3 units to the right and then 2 units down. And that's it. That's all we're going to focus on today. What do h and k do to a function? So it gets a little bit tricky because of the h value, and I'll show you why. So let's go back to the notes. I think I'm all done with graphs for now. Okay. So here's a pretty typical problem that you'll get in Algebra 2 regarding transformations. Let's make a function called f of x, a new function f of x, and we'll call it 3x to the power of 4 minus 6x plus 2. So we've got this function. We've defined a function as f of x. Now let's transform this function using this transformation form up here. All I'm going to do is change the values of h and k. So let's have a new function called g of x. G of x is going to be equal to f of x plus 7 minus 4. All right, so like I said, pretty standard problem in Algebra 2. What we're going to do with this function, this g of x, is describe the transformations. What transformations have taken place going from f of x to g of x? Remember, now that we have transformation form, we don't really need to worry about what's inside of f of x. It's universal. This is going to affect every polynomial function the same. Now, one more reminder, just to kind of reiterate, we're not changing the values of a and c yet. So we don't need to worry about the a value that would be in front of f or the c value that would be in front of x. All we're worrying about is h and k. So let's define those and then talk about what they're doing. So our h value, what does h equal? And this is what I was saying, it gets a little bit confusing. We know that it says x plus 7, but remember this form up here, it goes x minus whatever that h value is. So I must have done x minus, now the h value that I plugged in, to make it equal positive 7, I would have plugged in for h here, I would have plugged in negative 7 to get x plus 7. So the h value of this transformation, it's actually not positive 7, it's negative 7. So since the h value is negative 7, what does that mean? What are we doing in our transformations? We are shifting f of x to the left 7 units. We're moving everything in f of x 7 units to the left. Now let's talk about k. So the k value is pretty easy. It's just going to be this constant value on the end. That's just negative 4. So what does that mean for our function? We are shifting f of x down. We are making everything in f of x go down 4 units. All right, and I guess just to verify that, I can show you on Desmos, and that'll be the end of this video. So let me go back to that graph here. Sorry, what did I say f of x was? I said 3x to the power of 4 minus 6x plus 2. And now I'm actually going to get rid of all this stuff, really make it clear. So I define g of x as being f of x plus 7 minus 4. And you should see that pretty clearly. I went from like this point, I moved it 7 units to the left and then 4 units down. So 0.7 minus 7 gives you negative 6.2, or something pretty close to that. If I take this value and subtract 4, I get this value. And that's really it. So again, the h value gets a little tricky because the sign essentially changes inside of parentheses right here. And the k value is very, very simple. It just shifts the function up or down depending on what this value is. Had I made it positive 4, everything would have went up 4 units. If this was negative 7, that would have meant I went to the right 7 units. All right, hey, that does it for this video. Thanks for watching. I'll see you all in class. Goodbye.